Many structures in the world have been produced against possible earthquakes with a marvel of engineering. These structures can survive even earthquakes of magnitude 8 without being damaged. Here are 8 of the best earthquake-resistant structures. Mori Tower. Japan, one of the first countries that comes to mind when the word earthquake belt is mentioned, is located in a very active region in terms of seismicity. There are many structures designed accordingly in Japan. According to the information on the official website of Mori Tower, it was designed as a structure to be entered in, not to escape from in the event of an earthquake. Damper engineering is used for seismic resistance, and 192 liquid-filled shock absorbers are used in this structure. As a result of the shaking experienced during the earthquake, these liquid-filled shock absorbers are shaken in reverse to resist the shaking. Mori Tower, which has one of the most effective methods used in this respect, is on our list as a very safe structure in the event of an earthquake. New Wilshire Grand Center. Since the Southern California region is located in an earthquake risk area, seismic adjustments were made to the buildings in the region. New Wilshire Grand Center, the tallest building in Los Angeles, was traded in accordance with the new guidelines under these regulations. This building, which was previously discussed that an earthquake could create a whiplash effect on its upper floors, now has a very solid appearance. 30 struts are used in 3 parts of the building, thus allowing the facility to resist vertical and lateral forces. In order to support these struts more strongly, an additional restraining belt is included in each unit. This particular belt is both stretchable and compressible. Now, New Wilshire Grand Center takes its place in Los Angeles as one of the safest buildings in the USA. Komatsu Seirin. Japanese textile company Komatsu Seirin uses a high-tensile line developed from carbon fiber to strengthen and earthquake-proof its facilities. Kengo Kuma and Associate, the architects of the facility, chose to attach 1,000 of these high-tensile rods to the roof of the facility. In a possible earthquake, the horizontal force applied to the facility will be minimized and the building will suffer the least damage. Sabiha Gakuen Airport. There is also a familiar place among the most earthquake-resistant structures. Sabiha Gakuen Airport was built in accordance with the expected major earthquake. The 2 million square foot complex sits on more than 300 seismic isolators. Thanks to these seismic isolators, in a possible earthquake, the building moves as a single whole and minimizes the damage level. Considering how risky an earthquake zone Istanbul is, it is important for the region that this structure is resistant to seismic effects. This design reduces the intensity to be experienced in a possible earthquake by 80%. The mind-blowing fact about the Taipei 101, built in Taiwan, it's home to the world's largest tuned mass damper, TMD. This system basically consists of a giant metal ball that resists large temporary loads such as wind and earthquakes to reduce swaying of the tall tower. When large forces act on the tower, the TMD swings in the opposite direction, absorbing the transient forces thanks to the mass of the ball, keeping the entire building in balance. Philippine Arena. The Philippine Arena is the world's largest domed arena and stretches along the Pacific Ring of Fire, home of the world's most famous and active chain of earthquake fault lines. Thanks to the earthquake system applied in the arena, the superstructure remains stable while the underlying system moves. This system, the gap between the main structure and the basic system, is provided by the formation of rubber, which has a high energy dissipation feature. The Pyramid of Transamerica. The Transamerica Pyramid is an iconic 1970s structure located right next to the San Andreas and Hayward Faults in San Francisco, California. When a 6.9 magnitude earthquake hit the building in 1989, the upper floors of the multi-story structure swayed almost 30 inches, but the building was not damaged by the earthquake. This feat comes from a 52-foot deep steel and concrete foundation designed to move with seismic loads. Vertical and horizontal loads are supported by a unique truss system above the first floor with inner frames extending up to the 45th level. The complex combination of these structural systems makes the building resistant to oscillating movements and allows large horizontal base shear forces to be absorbed. Burj Khalifa. Burj Khalifa in Dubai is one of the most durable buildings in the world. The structure consists of mechanical floors where the buttress walls connect the perimeter columns to the inner walls, so that the perimeter columns can support the lateral resistance of the structure. The verticality of the columns also helps to carry gravitational loads. As a result, the Burj Khalifa shows superior resistance to both lateral and torsional movements.